All right, so we're going to talk about properties of liquids and how it relates to the intermolecular forces within that liquid. So remember, your intermolecular forces, you would have to draw the Lewis structure, determine if it's polar or nonpolar, in order to know if the intermolecular force is London dispersion, dipole-dipole, or hydrogen bonding. The other thing you have to remember is that London dispersion is the weakest and hydrogen bonding is the strongest. So freezing point is one of those properties that depends on the intermolecular force. The freezing point of a liquid will increase the stronger the intermolecular force, meaning those molecules that have hydrogen bonding have a higher freezing point. It's going to take more energy for them, they have to freeze. Surface tension is another unique property for liquids. Down here in this picture, you can see our water molecule is going to be able to hydrogen bond with all these other water molecules around it, which kind of pulls it all together, which increases the surface tension of the water. And that's also why water tends to form spheres. So if you ever have like a newly waxed car and you pour water on it, the water beads up. When water falls from the sky when it rains, it forms that droplet because it's a sphere, and then gravity causes the sphere to form the top part of the droplet. Capillary action is the rising of a liquid in a tube. The stronger the intermolecular force, the better at capillary action. So water can go up the tube easily where mercury can't because water has a stronger intermolecular force. So that's how plants can draw the water up from the roots. Another property of liquids is viscosity. Now, a lot of students mess up on the definition of viscosity. Remember, viscosity is the resistance to flow. So the stronger the intermolecular force, or even just the more complex the molecule is, the molecules are together, closer together, so they resist that motion to flow past each other. Heat of vaporization is the amount of energy needed to turn 1 mole of a liquid into a gas. The stronger the intermolecular force, the more energy is going to be needed because we need to separate those molecules. So the stronger they're attracted together, the more energy we need to pull them apart. And the last two, vapor pressure, which is the pressure of the vapor, the gas, that pushes back down on the liquid. So think about over here in our picture, these blue gas molecules hitting the blue surface. That is the vapor pressure when the gas hits the surface of the liquid. The stronger the intermolecular force, the lower the vapor pressure. And that's because they can't escape the liquid to form that gas. So the blue over here is showing a low vapor pressure because it has stronger intermolecular forces, where over here in the red, that's the weaker intermolecular force. And so we have more gas molecules because they were able to escape the liquid. For boiling point, the stronger the intermolecular force, the higher the boiling point. Again, if we're really attracted to each other, we want to turn it into a gas, we have to separate them. And so if they're strongly attracted, it's going to take more energy to let them kind of expand away from each other. So those are the properties of liquids.